I am Heather Kirksey. I am the VP of Community and Ecosystem for the set of networking and telecom-oriented projects within the Linux Foundation. I will be moderating your panel today. And just as a reminder, we do have the chat window open. We will be monitoring it. So if you have any questions that come up as you hear our speakers go into detail, or if you have something related to the topic, we will be monitoring it, and we hope that we can answer you in real time. So welcome to our Cloud Native 5G Core Network panel. We're going to be talking a little bit about sort of the requirements around 5G and deploying them, and how we believe that cloud native technologies really support that on the part of mobile operators worldwide. All right, so I am looking for the advanced button on the slides here. There we go. All right, so I just want to kick off the panel by talking a little bit about the 5G network. So what you see here on the slide is sort of a physical layout to a certain extent of how 5G networks are deployed. And one of the main things that I want to point out is that tens of thousands node there on the far left. 5G brings a number of really amazing and interesting capabilities, especially around low latency and high bandwidth. But the physics of actually delivering that, and this is the thing that you can't actually get around with software, the basic radio physics of developing that high bandwidth, low latency service, is that we need lots of nodes connected very close to the connected end devices. So what that means practically is that there are going to be lots of very small, very close to the end subscriber nodes. And then as you go further and further back towards the core network where different mobile functions happen, you've got your low thousands of edge data centers, your hundreds of local DCs, tens of regional, and then a few sort of public cloud instances. So it is a tiered architecture that does introduce complexity, but it is so that we can actually process the needs of the radio, as well as the plethora of services that we expect to be delivering via the 5G network. And as I said, it does introduce complexities around networking, around security, around privacy, and around how to manage both the services and the network as we deliver those across these nodes. So moving to the next slide. I could get a little bit of help. There we go. So this is more of a logical view of the network and starts to talk about how the various control plane and data plane functions within a 5G network look, and some of the technologies that we believe CNCF and the cloud native ecosystem bring to bear. So one of them, obviously, is service mesh. I mentioned the networking complexities that this tiered architecture brings, as well as the networking complexity around delivering a number of services with different latency and bandwidth requirements. Security is also obviously very important. No telco in the world really wants to find themselves in the headlines because they have not provided a secure service to their end consumers. And there are both sort of very important control plane things like signaling, setting up a call that really have inelastic requirements, as well as wanting to deliver high quality video, as well as the cool things like VR, AR, connected cars, things like that. And so we really believe that there are a number of technologies that can come into play and really help us deliver these services. And that's what the main meat of this panel is going to dig in today. So with that, I want to introduce our panelists, and I will do it in alphabetical order. So first up, we have Srini Addepalli. So Srini, give a wave. He is a long-term expert in networking and security, having worked in the industry for more than 23 years. He's a principal architect and technical strategist at Intel, where he focuses on cloud native and edge computing with a special focus in his core areas of expertise, networking and security. Next up, we also have Balaji. Ethirajulu, who is a senior director of product management at Ericsson. I have known Balaji for a very long time. He has been a long-term contributor to product management, marketing, and business impact into the open source community, and has given much to SDN, NFV, cloud native over the years. And he's a long-term open source advocate, as well as a subject matter expert in 5G services and telecom services across the entirety of the networking stack. We have Tom Kivlin from Vodafone, where he is leading the adoption of cloud technologies and within Vodafone across both IT and networking workloads. He's a principal architect and subject matter expert, and also very active in open source communities around requirements and deployment architectures for telecom and 5G mobile operators, using all of this great software that this group is producing. And finally, last in the alphabet, but certainly not least, we have Ramki Krishnan, who's a subject matter expert in compute and network infrastructure at VMware, very active in a lot of these areas, and he leads VMware's technology strategy for blockchain and its intersection with cloud native. So welcome everyone to the panel. I really appreciate all of you being here and bringing your expertise to our conversation this morning. So let me kick off with the first question, and I'd like to start by directing this to Tom. We talked about some of the complexities and some of the needs in the network, as well as the way that we believe some of the technologies coming out of Kubernetes, service mesh, containers help address some of those challenges. So my first question to you is, are service providers ready to embrace a lot of the new paradigms and new concepts of cloud native as they are rolling out their 5G services? What are you seeing internally for Vodafone?
So to answer the question, I think generally, yes, we're ready and we're certainly getting there. It's a big shift from traditional networking, and certainly from VNF based network services. There are a ton of challenges, clearly, and I think in reality, I think you'd be hard pushed to find very many production network functions that are orchestrated with Kubernetes today and containerized. But there are an awful lot of industry initiatives working on it. And I think going back to the first slide, the sheer breadth of different network applications in question, they will each have kind of useful periods of time to which cloud native is going to become useful to them. So, for example, the mobile core, 5G mobile core, is like, I would expect that to be containerized in cloud native before we see huge changes in, for example, the radio network or perhaps MPN. Now, initiatives like KubeEdge may speed that up, may change it, may help, and there are a ton of other things that may change that statement. But in terms of we're ready to deploy, I'd say not today immediately, but we're certainly working towards it in the next few months.
Heather, if I may add a few things, what Tom already added. Yeah, so first of all, welcome audience again from my side as well. I think Tom said it pretty good here, but I would like to add a few more things. For example, I can say cloud native technologies are already sort of used in 5G network. Let me give an example. For example, 5G core is really based on microservices based architecture. And many operators are doing trials and POCs, so they are sort of in the network. And that's the biggest piece that is actually microservices based. But the key here is, let's step back a bit here. Telecom networks are highly complex, right, compared to the enterprise networks. They really demand very stringent requirements, right? For example, reliability, high availability, security, and much more. And also important, it's always real time, right? That's one aspect. The second big aspect for telecom guys, for the telecom deployments, most of our network, they are grown, more than several decades, right? They're all brownfield today. So that means when we bring in a cloud native architecture, they got to interwork with all the legacy system that is already been put place, right? Billions of dollars invested already, and vice versa. Both the legacy need to work with the modern infrastructure, and the modern infrastructure need to work with legacy, because the services will flow across these different platforms, right? So that means to realize the full benefit of cloud native, right? Cloud native brings a lot of benefits, right? Operational efficiency, the flexibility, faster time to market, and enormous scale that it provides. But how can we realize that, right? Not just having, I have actually migrated my network function to cloud native architecture, right? From RAN, from the transport, RAN meaning the radio network, right? Radio network, the transport, and the core. But that's not enough. To do the real, to realize the full benefit, you need to have a modern next generation orchestration and management system on the top. The problem there is today, most of the systems, operators, IT system, I think Tom can vouch for that, they're sort of legacy. It's a really, really cumbersome, right? So to do that, so you need a fantastic orchestration system here, right? That's what I want to say. Sorry, my PC may boot, but let me, I will hand over to Heather to you. Something wrong in my
Very
PC.
cool. Yeah, thanks for adding some color there, Balaji. And actually, before we move off this question, we had something come in from on the chat from Jeff at Comcast, and this is directed back towards you, Tom, which is going back to our telecoms ready to embrace this. How are you internally handling that technology skill set and paradigm shift? Across multiple groups, are you sort of doing reorgs? How are you handling, both the reskilling, but maybe also the reimagining of, how workloads work in cloud native? Could you speak to that just for a minute, Tom, before we start diving into some more of the technology discussions?
Yeah, sure. So, without kind of going into the detail of Vodafone's, org structure and operating model specifically, I think that the key parts to this are as Jeff mentions, about skill set. So there's been a global training initiative to introduce cloud native concepts and technologies to all technology functions, whether it's development, operations, networks, etc. In addition, there's been an initiative to start to consider our network as a platform. And whilst that's a bit of a buzz phrase, it's been quite useful in ensuring that even the legacy or traditional systems are accessed and controlled as platforms, and so via APIs and with as full automation as possible. And so whilst there haven't been huge amounts of org changes, there have been some. They've been primarily to aid that approach of allowing our network across all the markets that we operate, primarily in Europe now, and across Africa, to be accessed and managed and consumed as platforms, and that kind of cloud native concept of you consume it via API. There's a set contract in place that it might be the OSS is consuming, it might be the BSS is consuming, it might be the consumer is consuming. If you have that concept and that culture in mind, regardless of which layer of the system you're dealing with, it could be the physical hardware. If you're still supplying that, providing it as a platform, then that layered approach to build up a service is going to mean we're kind of decoupling things and able to build our offerings more in a more agile way, small a. So hopefully that answers the question, Jeff. If not, please ping me in the Slack channel, and we can take it up some more.
So thanks for that. I mean, I think it's really good to sort of start off with kind of the cultural and org processes that taking in a new technology to support new services means. Sort of going back to some of the technical complexity. One of the things we mentioned is, with all of these tens of thousands of nodes and sort of the tiered architecture from, very close to the end through edge, regional, back to the core. There's obviously both from the types of services that telecoms offer, as well as all of the interconnectivity of all of the tens of thousands of end nodes. Networking obviously is a big challenge for this. And I know that lots of discussion around service mesh to meet these telecom needs has been going on in the industry. So maybe Srini, I'll throw this to you. How are you viewing service mesh, and its ability to help manage the network complexity and to enable these services to run smoothly and in a cloud native fashion?
Yeah, thanks, Heather. Yeah, service mesh is kind of becoming popular in enterprise, right? And the reason the service meshes were created is for microservice architecture. So as you said, there are multiple microservices for a given application, and if they need to communicate with each other, they need to have load balancing themselves, they need to have some mutual TLS endpoints themselves, and they need to provide some kind of observability. So that is a challenge for any application developer, right? What service mesh is doing, it is taking away those mundane activities that are needed for microservices into a central place called service mesh. So it has its own sidecar for every microservice, and there is a Istio control plane, for example, one of the popular service mesh technologies today, and it would take care of the mutual TLS, traffic management, and any observability, all that. But how do we translate that into 5G? Right? But fortunately, the way 3GPP defined 5G core functions and their interactions actually kind of falls into microservice architecture, right? And they are going with all HTTP, JSON, gRPC-based communication, and it's similar to enterprise applications. So we believe that service mesh technologies like Istio and Envoy would benefit even the 5G world. But as I mentioned, right, there's one aspect of service mesh is that if all the microservices are sitting in the same Kubernetes cluster, for example, they can work fantastic, right? But as you mentioned, 5G in general is disaggregated. Like there are different components or different microservices or different network functions sit in various Kubernetes clusters across geographic locations. So you require communication among the microservices in different locations. That's where the manageability or the central orchestrator or multi-cluster service mesh is very important. So that is one aspect in my mind would be needed in leveraging service mesh in 5G world. So there are some open source activities going on, like I am in LFN ONAP community, and we started to think about how do we basically have this multi-cluster service mesh where we automate the control plane or Istio control plane every Kubernetes cluster to enable communication among the microservices. Sometimes some microservices need to be exposed to the outside world, and sometimes the microservices need to go to the outside world. So how do you do all these three kinds of things in an automated fashion based on how microservices are deployed in various locations? Yeah, that is somewhat going on there. So yeah, as I mentioned, the service mesh provides security, traffic management, and observability. And we believe it is equally valid for 5G core network functions. And but only additional item which we need to worry about is automation across multiple clusters.
Obviously, automation for all of this is going to be key. In terms of how to do that, I think Balaji mentioned that earlier. We have a follow-up question specifically on service mesh and its use in 5G, which is, do you see any conflict or overlap between the NRF, 3GPP defined NRF, and typical service discovery approach in Kubernetes? So, for example, querying the NRF for NF addresses using labels, and does that impact the service mesh sidecar model? Are you seeing those coming together and dovetailing in terms of coalescing around a single approach? Or is there some conflict between maybe ways that we've typically done things in telecom and the way that sort of a cloud native service approach comes to the table?
Okay. I can take it up.
I'll throw that out to the entirety of the panel for who feels comfortable. It sounds like Srini, you want to sort of address that?
Yeah, let me start. Yeah, certainly that is one aspect, right? NRF, basically provides a ability for people to other network functions to register to it, and then any consuming network function can refer to NRF to figure out which producing microservice to talk to. That's certainly some overlap on that aspect with respect to service meshes, right? But at the same time, we believe that service mesh technology can work with the service discovery and registration mechanism that is already available in 5G. So it will treat NRF as any other microservice, I guess, from a service mesh point of view. But at the same time, there is an opportunity, right? There's something which we are discussing in the community also. There's an opportunity to see whether some Istio plugins can be developed to take care of NRF functionality internally, right, within Istio, right? That way you can avoid maybe multiple lookups, service lookups. But certainly, the reason why it cannot we cannot use Istio as is in place of NRF is that NRF is used. The selection happens beyond traditional URL or DNS kind of entities. It happens based on other 5G specific criteria. So I would imagine that initially that kind of service registration will continue with Kivirin 5. And Istio will continue to work separately. But over the time, I do see there is some convergence possible using developing plugins to Istio, maybe mix-up plugins or something.
Cool. Daniel, if you have any sort of follow-up or that didn't answer your question, feel free to chime back in. And then another question from Jeff, specifically around yet another sort of mobile core function. Do folks on the call believe that the UPF is ready to be cloud nativized with the disparity and solving data plane challenges? If anyone wants to chime in here, maybe Tom, is that something that you've been looking at as you've been looking at how to deploy this for your own mobile services?
It's a very interesting question. There are certainly challenges, and there are a ton of different projects and initiatives looking at how to solve those. I think in reality, there's probably another few months before we, as an industry and certainly as a company, settle on this is the right answer for us. And it revolves around a bunch of different activities around how networking is presented to containers, how the UPF applications are containerized, how hardware acceleration is presented to that software, and there's tons of companies, all of the companies on this panel and others are all involved in activities around that. So I don't think there's a single and simple answer today, but there's certainly lots going on.
I don't
know. I think it was on just before.
That there's still some things to get alignment around potentially.
I can quickly add to it.
I mean, you've got to remember that Kubernetes and its networking model was not built for high throughput data plane applications. It was built for web scale. And so there's had to be a lot of, I wouldn't say re-engineering, but additional engineering to bring the benefits of Kubernetes and containerization and cloud native to make it usable and of benefit to data plane applications. So it's still going to be some time, I think, before we go, yep, that's the magic bullet.
Yeah, just to add to it, right, in 1 minute. There is a lot of stuff happening in Kubernetes world to make the data plane or user plane kind of or packet processing kind of work in a high throughput, deterministic fashion with low jitter, right? Such as you might have seen efforts such as CPU affinity, isolating the CPU cores for a given microservice, and then huge table support, NUMA awareness. So many of those functions are being developed in the Kubernetes world to leverage, to deploy even packet processing kind of applications in the cloud native Kubernetes.
Cool. All right. So, we've talked a lot about networking and how Service Mesh can address those challenges. I wanted to move into sort of the other big topic on our panel, which is around security. So obviously security is very important. If you think about the things that you are doing on your devices and will continue to do in 5G, it's an issue for subscribers. It's sometimes a regulatory issue. And sort of securing all these services when it is this big public mobile network, as opposed to maybe a cloud that's just being used, within an enterprise, certainly brings challenges. And so Ramki, I wanted to throw this question to you. I know this is a particular area of expertise and passion for you. So could you talk a little bit about, how some of the work that you're doing around bringing security concerns into the mobile network that is, cloud native?
Ramki, you're on mute. I can't hear you.
Are we having some technical difficulty with Ramki? I think it's saying we might have some connectivity issues. I love that we're here doing a telecom networking panel and sort of experiencing some connectivity problems in real time. It sort of goes to show, the challenges really are real and we all experience them every day. Ramki, are you back yet?
Maybe I can take up that.
Yeah, I was going to say, so if you could take it and Ramki can sort of see if we can get him back in, and then he can sort of add to whatever you have to say.
Yeah, so of course, service security point of view, Service Mesh does take care of mutual TLS, authentication, authorization, those aspects, right? That's not that challenge is taken care by Service Mesh technologies. But there are few more security aspects that need to be considered, especially if we are talking about 5G functions coming on edge locations, which may not be physically secured very well, right? There may not be physical guards, to man the locations there. In those cases, the infrastructure security becomes very, very important. So how does one ensure that the system is not compromised, right? The platform attestation is very important. So how does one ensure that whatever secrets, passwords, private keys that are basically shipped to the are configured and the network functions running in the edges, how do you know that they are not compromised? How do you know they are not stolen? So key protection and platform application they become very important to figure out something bad happened. So that is one aspect. Second aspect, which I hope Ramki is around, the blockchain. Ramki was talking about, especially when you have multiple operators, sharing some billing data, some commercial data. How do they ensure that those are not compromised? So that's what Ramki was talking about, ledger concept. Ramki, are you there?
Ramki, are you back with us?
Apparently not.
Okay.
Mhm.
All right. Cool. Does anyone else on the panel want to sort of add anything onto the security discussion? Well, we are getting close to time, and I wanted to throw out one final question to all of our panelists, which is, we've talked about some questions were raised, for example, around the UPF and how to cloud nativize that. And, Tom was indicating that there's still some work to be done in terms of coming up with the right solution. The question I would like to leave with the panel is, for any developers in any sort of CNCF project, whether it be one of the service mesh projects, Kubernetes, CNI, other projects, if there is one high priority item to work on, within the context of their projects that they should take back to their developer groups in order to enable cloud native technologies to provide the underlying platform for the next generation of global communications infrastructure, what would that be? And we'll I can start with Tom, but I'd love to hear from each of the panelists what you would like to see happening there. So one high priority item for developers on the call to take back to their developer communities to work on to enable the mobile network cloud nativization. Making up words here on the fly.
I was going to say we need to all agree on what is that word. One thing is really difficult. I think the one thing I would suggest is getting involved with the TUG, so the Telecom User Group. It was there was a session before this panel, which will be available on demand, and there are a few projects kind of being corralled within that user group. And I think one of particular note is the network service mesh. I think that's got tremendous potential in terms of its ability to help with network intensive workloads and the security of them. So that would be my suggestion.
I can add one thing.
Balaji?
Hi, Heather, So the key takeaway for the developers and in fact, the overall cloud native architecture in the community is, for me, as I explained at the beginning of this, panel, cloud native architecture, yes, we are bringing into the network in a brownfield network that's already been built. So it's not an isolated thing sitting in an enterprise on-prem or in a private or a public cloud, right? It has to interwork with the existing network, number one. Number two, when you create a Kubernetes cluster, 1 or 2, 3 clusters, there is an orchestration and a management system that's deploying the service over the PNF, that means physical network function, that is legacy. Then there is a VNF, virtual network function, and there is CNF, what we call a cloud native network function. The services will flow across all of this. So that means the Kubernetes cluster, we need to ensure all the APIs and interfaces well managed with the higher level orchestration system, whether it is legacy or a next generation orchestration system. That pipe is fundamental to realize all the benefits of cloud native architecture.
Yeah, I agree with I agree with Balaji. I also feel that the problem statement today is that because of a disaggregated nature of 5G and because of large number of locations, Kubernetes clusters, the automation becomes very important. Whether it is multi-cluster service mesh or multi-cluster security or multi-cluster networking, all that part of that automation becomes very important. So that is my takeaway. That that's the community needs to kind of focus on.
Okay, awesome. And then Ramki, do we potentially have you back? Are we able to get an answer from you to that question of what's the most important thing to take back to the developer community?
Are you able to hear me now?
You can. Your volume is a little low. If you can turn your volume up a bit.
Better now?
We got a little bit of feedback there. All right. All right, I think Ramki had to sadly drop again. I'm very bummed. Ramki has a lot of really great insight and in fact was sort of the driving force between pulling this panel together. But with folks' questions, we were only able to scratch the surface of this. We will, as speakers, be going to the Slack channel so that we can continue the discussion. So if people want follow-up questions, I would encourage everybody to ask Ramki about some of his insights into security in the 5G network using cloud-native technologies, as well as any other topics around this. We will be in the let me make sure that I am getting this correct. That we will be in the number 2 KubeCon service mesh channel within Slack. And so we will, as panelists and speakers, I'll make sure that we're there so that we can continue the conversation, answer further questions. And I encourage you all to join us there. I hope everyone is having a great virtual KubeCon. I miss seeing folks in person. But it's nice to at least interact with folks virtually. And really thanks for the questions we got from the chat and great. And enjoy the rest of your KubeCon. Hope to see you in the Slack.
Everyone.
Yeah,
Bye-bye.
Thank you, Heather. Thank you all. Bye.
Thank you. Bye.